A very good morning to you all. We are again with the power system operation and control subject. The standard connection models were discussed in the earlier mode of interaction. Let us revisit and go ahead with the further requirements. So in the next class, I will present you some sample examples which will make you more insight for these kind of connections. Meantime, let us revisit again. The standard connection communication models required in the substation in the power system operation and control are likely be classified as radial serial circuit like, wherein the master station always gets interconnected to remote terminal units or a remote station using communication mechanisms. Those communication mechanisms have a connection like RTU to MTU. So it is a wired or wireless communication. Each field device, it may be a generating station, it may be a load center, it may be a transmission subsection, whatever is that, is interfaced with the master substation or a master station through MTU, so that it keep on getting the information from the field as well as sending the information to the respective field device. So such an interconnection can be like this as I am trying to point out here, which is a radial serial circuit. It is actually a point-to-point. Master station is communicating with the serially to an RTU1, and it is a bidirectional communication. It is connecting to it and getting information from that. Like it may be connected to RTU2, RTU3 like that. You can see it is a radially emerging line from the master station. Hence, the structure look like a topology star. Hence, it is called radial serial output or radial serial circuit. It may be a multi-drop point also. You can see here, there is a direct connection from master station to remote station through network. This is another way of representing the multi-drop circuit, which looks similar, but there is a common channel being shared. You can see here, the station send the information, polling information on this transmission infrastructure. From these, all are connected in the concurrent parallel. So RTU1, RTU2, so many RTU in N number are connected to this, will respond according to their turn. Master station is having a connectivity with the RTU1, RTU2, RTU3 as well, and it is having the information channel common. But here there is a dedicated connection from master station to remote station 1, 2, 3 like that. This provision of one-to-one connection is not here. It is a common channel being shared and from which tappings were being taken, or it is connected such that networked appropriately. This we call as multi-drop. From the single master station, information is dropped on the line and it is getting connected to several RTUs in this regard. Then another we have a far away remote area. How we can magnify it? Suppose a master station, if I visualize having a router, the networking connecting mechanism router, and it is having a wide area network connectivity between master station and the remote end field station or even RTU. This router via the wide area network gets connected to the end device through a router, and it will switch into number of tappings like electronic device 1, intelligent electronic device 2. So many devices are interconnected. They are interconnected to this switch, and this switch in turn route it to the master station. Now we can imagine this like an internet mechanism. This as a local LAN from the internet provision switch. How individual computing facilities get connected to internet from this switch, how it is routed to the service provider. Likewise, the master station gets connected to individual end devices via this wide area network mechanism, wherein the information from the master station is routed to a router and the networking mechanism wide area network, and other side at the field, it receives the information via the router and it will switch into number of possible interconnections as 1 to n. and it is bidirectional mode of communication. Then similarly, we had discussion on individual. Like this, we had individual standard connection by block diagram. This is there in your textbook, Dr. K. Umarao as well. So it can be a direct mode, point to point. There could be a master equipment, a slave equipment, directly one-to-one. There is a physical connection. This device will send the information to the master, ready to go. This is connected to only single device. There is no second device to get the information. It is the only direct, dedicated point-to-point connection. The master may be a personal computer or a programmable logic controller. The slave may be a sensor. Slave may be anything like a transducer, which transform the information of one physical form to electrical signal, like this. It can be a direct mode to serial multi-mode, wherein we find master is not only communicating to the slave 1, slave 2, 3, 4, like that several. This is another way of representing master is getting connected to field devices by parallel mode of connection, multi-mode. Then this must be having an ability to communicate with the slave 1, slave 2 or device 1, device 2, device 3 using the common channel. The same thing, it is in a local plan. If it is far away, maybe the devices are not responding to the protocol, the language of communication, what it is trying to get into. There can be another view of this, which I have shown in the right upper half. Master system, PC or a PLC, having a serial communication, RS232. The functionality, serial communication, is again made into parallel. RS485 or fiber optic converter, serial to parallel converter. This will switch into number of slave 1, 2, 3. Whatever I have drawn the diagram here is a similar diagram where the device which provides this functionality is shown here. It is RS232 RS485 converter. You might ask me, what is this exactly? You may have nowadays devices, the computer peripheral. A mouse is a device. Earlier we had a PS2, round connector for the mouse. Nowadays you find a USB, universal serial bus connection. Now you find interface between serial PS2 and USB. We have a hardware and device which will convert the signal from one format to another, which is compatible to communicate. Likewise, the serial RS232 to the RS series 485 converted to multi-mode drops. This is a converter from serial RS232 to serial RS485. Multiple devices are connected, fold upon. This will fold. What is that device has to respond? Only that device will respond. Rest all will remain idle. So this way, this is a converter which makes the possibility of either side connection. The similar diagram was shown in a simplified version. It may be far away, the plant to plant. There is a communication station, and far away there is an equipment whose information I want to get connected to. It may be a physical device, I can connect directly the wire. If it is far away, then I should have master unit, proper communicating device. We call it a modem, modulator or a demodulator, which will communicate and transmit the signal over the public line or service provisions, so that those service provisions will have an alternatively other side similar mechanism interface to the device. So master device via the transducer, via the converter, route the information via the service provisions provided to the end device, and the end device will return the information on this way. This way, a serial communication in a very large distance or maybe far away places we can connect. This you can imagine in a process industry or in a power system where control center is really far away from the device, and you want to connect it through that device, get the information and take into. This is how the communication mechanism shall fall into different categories. When we move into single study, what's that? RS232 master unit connected to slave unit or a functional or intelligent electronic unit, MFD, multi-function unit, like that, which is a slave or a device which gets the information and ready to transfer it to the master as and when it queries or it requires. Then communication mode shall be something like this way. The master serial communication will have a modulator demodulator, which will transmit the signal via the service provision to the end device. End device will respond to the feed and get to the requirement. This is called one-to-one direct connection. There is no splitting of wires or splitting of signal. It is a end-to-end connectivity. This is by RS232 mode. You can imagine a multifunction unit number 1 connected to a master unit. Directly it is connected to that. There is no second device responding for this request like that. So this is a DNP protocol, distributed network protocol in a physical layer support point-to-point communication. So I was interacting with you all in the earlier class itself. It is a networking, electronic networking and communication pattern. The 7 layers of OSI, 7 layers of which how the data transmission takes place from physical level to the application level. Like that the protocol physical layer supports distribution network protocol for us. It is a point-to-point communication. The 2-wire, which is a half duplex mode, usually uses RS485 or 2-wire mechanism. It's nothing but, suppose I want to make a 2-wire RS232 serially to the device which is responding for RS232, then it is a half duplex. One because master is sending a information, same time slave cannot send the information. There should be a proper time edge synchronization. When master and says this is ready to send the information, this should acknowledge ready to receive the information. Then it will send the packet of information. Once it receives, received information will come back. Once this is ready to request the information, this must be ready to send the information. On acknowledgement of signal, it will transfer the data. This is called half duplex. Both the information transfer, master to slave, slave to master, will not happen at a time. That's called half duplex. Full duplex means what? Master can send, receive. Slave can send, receive. There should be a proper channel for that to do that. That is not provided in this kind of 2-wire point-to-point mode of connection, which is half duplex. Usually either RS232 or RS485. Suppose I have one device, it is like this. Suppose I have multiple devices down the line. I can switch to second device, third device. Then I must be using RS485 switcher, which you have shown me. RS485 switcher will divide either 1, 2, 3, 4. This is responsible to send the information to respective device only and get the information from respective device only. That's what is shown here. So this signal converter may be RS232 or a modulator demodulator, ping up and connect it to, or it can be RS485, or it can be fiber optic cable which can communicate end to end. So this way, the mode of communication shall be 2-wire point-to-point, wherein half duplex is only possible. Then it works in physical layer. Then it is, if a modem is used, then the interface to a modem is usually uses V24 ITU standard. It means when there is an RS232 communication, physical copper wire will run. If it is a modem, it can be wireless. So this is how modem is interfaced with the V.2.4 ITU standard. The 2-wire mode does not support full duplex. I was speaking the same thing, half duplex only. If it is a full duplex, it should be both the side confirmation. Master can send and receive, and at the same time slave can send and receive. That we call as a full duplex. Okay, only the half duplex is possible. So with a point-to-point mode, there is no possibility of collision. As we see, the data transfer from master to slave takes place and slave to master takes place. If it is in a full duplex, there would be a possibility, or there could be a possibility of collision of data. So data may be collision, and there could be a loss of packet, loss of information, or anything which is an erroneous data be included in that due to collision. So that is not there, because it is connecting end to end by point-to-point connection only. The master transmits the frame, then the slave responds. I was speaking about it sends a handshake signal. It acknowledges, are you ready to get the signal? Yes, it sends it. And when it completes, completion signal will go back. Like this, the concerned it takes a certain time to respond due to propagation delays. There is a configuration in DNP for setting up this time. It means it should be connected and configured such that such a transaction should happen within such a time frame. Time frame should be elapsed and immediately transaction should be closed. This is how two-point or two-wire point-to-point mechanism works. When another is the two-wire multi-drop. So this is usually a master which is communicating to number of devices. You can imagine in a generating station. At a generator, you have a master, a receiver of signal, a temperature, RPM, voltage, anything like that. These are called as intelligent devices at that time around a generator. Just imagine a situation. All together correspond to a information related to a generator number 1, which is connected to a master unit, which is generator number 1 data, which can go to a remote station later. It means this is an automation around a unit itself, around a plant itself. You can imagine slave number 1 will be generator 1, slave number 2 will be generator 2. Like that, you can imagine the situation about a periphery. Whatever all you interface, all those peripherals are interconnected to single master. In this mode of communication, single master must be able to recognize and poll the information on a common channel so that which slave has to respond. So that is an ability in RS-232 to RS-485 mode of conversion. You can see here, this is DNP, physical layer supports multi-point communication. The two-wire multi-drop. It is a two-wire, no doubt. Usually uses RS-485. When RS-485 is communicated, it is a multi-point. I have a splitting option. RS-485 converter takes the data serially, two-wire data. It will make a two-wire multi-point. Then these two wires will communicate to the slave as well. Before they get communicated, it will send the information called as an identification of a tag for the device number 1, device number 2, device number 3 first. Only that device will accept the communication, rest devices will not respond, they ignore it. Therefore, RS-485 is the communication protocol which is used there. Fiber optic or Bell Laboratories 202 modems are used in the physical system. These are the communication end devices which are hardware with a suitable configuration being used. The two-wire mode does not support a full duplex. As we were earlier interaction in the previous slide, only we have seen full duplex is not possible. It is going to acknowledge, which is I am ready to receive, send the packet. I have confirmed reception. Then it is going to send the information, I am in need of that. It's only half duplex. It makes the communication between master and slave only when there is a end of signal. Like you can say walkie-talkie. Are you ready? Yes. Voice signal. And it's complete. Signal complete. Then the other party, now I want to speak. Then he continues with the signal. And this kind of vocal communication commands, how they give, these master and slave devices will have to have such an handshake in the particular communication. So therefore, it is a half duplex only. With the multi-drop two-wire mode, there are possibilities of collision. You can see this. These collision properties were not there in the point-to-point. There was no discussion of collision. This is a dedicated connectivity with the master and slave point-to-point. There is no inclusion of external commands or external device data on the discussion channel. This was not having any collision, no possibility of collision. But here, as it is a multi-drop, each device is ready to receive the information on its turn, and there could be an error. Any slave could respond wrongly. The tag which is sent by mistake, acknowledged by any of the devices, they may respond unduly, and master may get wrong information from this, or it will start acting malfunctioning device. Those will have collisions in the channel. Those collisions will propagate to the master with the erroneous data. That's how these collisions are possible. This is possible because two masters or two slaves can access the line at the same time. The same thing, when a master, example, a master is trying to communicate multiple devices or a device, multiple devices can respond by mistake, by chance, like this. So therefore, to overcome this, DNP, Distributed Network Protocol, inserts a time delay after a loss of carrier. It means once there is a communication between these two, so the communication signal get lost over the communication width of time frame. Suddenly, there is a loss of information between the end devices. It drops it, it makes a pause. It makes, which is something going wrong like that. That is detected, and there could be a time delay, certain time after. Continuity of handshake must be done to ensure that the device is intact with the master or another device. So this kind of intelligence is adopted in the end-to-end connecting devices. The carrier is an indication that someone is transmitting on the two-wire bus. In two-wire multi-mode, all devices on the line must have some way of determining that someone is transmitting. This example from the slave viewpoint. Slave number 1, 2, 3, device 1, 2, 3 want to share the information to master. They should understand someone is already utilizing the channel. They should keep quiet till their turn comes, or they should not disturb the other communicating device for its appropriateness, because its data is also critical for the master. Likewise, there should be a configuration set in the intelligent devices at the remote side. They should understand if some device is communicating with the master, other device should be in a queue or should be in a waiting list. Like that kind of information exchange should be there in the knowledge. That's called two-wire multi-drop. This is a faster. It can access the device parallelly. Device number 1, 2, 3, it will access directly. There is no much delay, much hardware is avoided here. But the thing is, the collisions are possible. Collisions need to be overcome by intelligent programming of end devices in a systematic manner. Then 4-wire point-to-point. Now see the hardware complexity. Master is here, signal converter is here, slave is here, suitable signal converter is here. You will find two separate communicating channels. One is upcoming and down. Like that we have 4 wires, 1, 2, 3, 4. It means it is just like earlier what we had, dedicated 2 wires, half duplex. You can see here, half duplex. It can send only. It can receive only. When master is acting, slave cannot. That was the mode with the limitation of 2 wires. Now you will find here 4 wires. It is a full duplex possible. It can be RS422. Just here. Earlier I was RS485. RS485 is 2-wire multi-drop protocol communication. Now I have RS422 serial. It means RS serial 232, RS422 when I do multi-point and multi-wire point-to-point protocol. It is communicating from one master to one slave only. There is no doubt about it. But bidirectional communication is concurrently occurring. Device master is querying, it is sending. The slave is querying, slave is getting the information. This is called full duplex, but hardware is additional. 4 wires are utilized for that. For this suitable update in the signal transducer and the master and end devices must be taken care. This is how 4-wire point-to-point is used within DNP, Distributed Network Protocol, as a full duplex master-slave system. It's called master-slave. Both can query themselves as and when there is a need. Then the physical address standards used are RS422, RS232, and 4-wire modem. It may be very closer, it may be far away also. Then the modulator, demodulator helps for that. Since this mode is only point-to-point, there is no problem with the collision. You can see here, collisions are avoided even though there is a bidirectional communication. Transmit, receive, appropriate handshake signals are being utilized to acknowledge the communication start and end signal. Hence, collisions are avoided. But hardware and investment over here is different, but the technology-wise there is a change in the collision. Collisions are almost removed off. However, V.24 is used as a handshake system to control the communication. This is a communicating security signal which will appropriately ensure there is appropriate edge-triggered transmission and reception in a time frame going with the syntax by V.24 standard, which is used as a handshake to confirm when the master is sending, slave must receive edge. complete. Then slave is responding and communicating, it should understand. This time edge confirmation syntax is used in the V24 handshake. This includes DCD, data carrier detect. Means channel is free, channel is used by the device or available like that. It is checking is it. It is called as condition checking. Propagation delays are also used to allow the devices time to detect the loss of carrier. It means to say some data transmission is taken from master to slave. So certain time is expected to be spent in sending the data to the slave. If during that, even after that, data completion is not received, what is the meaning of that? Open. The signal either not reached there or it is a punctured somewhere, tapped somewhere. That is called as loss of carrier. Detection is utilized to ensure end-to-end connectivity of this. So therefore, it is more of communicating and keeping the intact with the end devices. Four-wire communication allows for a true full duplex communication, but in practice, it is rarely implemented. It's because it is not required, it is redundant. It is redundant when we make a master to query the slave. Or why slave require master to query sometime or all the time? It is the master to decide what information it expects from the slave. If slave is healthy, it will take care. If slave is in need, it will monitor. So that kind of communication being, that intelligence being programmed in the master and slave end-to-end connection, why this full duplex? So it is rarely used, it is not in good practice, that is the name. So now moving to the another aspects of which, once we have all these kind of communication standard connections and all, challenges for implementation of SCADA in power system. Definitely, when I have energy system, energy management system software in the energy control center, which facilitate the energy dispatcher to monitor, control, adopt good techniques so that such a operation ensures reliable and effective control of generation and delivery and dispatch to the end user to their satisfactory level. But when we want to operate in this due regard, there are so many challenges and there are some precautions and some investments one would need to take care. That's how the challenges and implementations of SCADA in power system identifies with the first one. It ensures fail-safe system operation on 24/7 basis. Yes, it is true. When I have an energy control center interface to all the end devices from the generating station perspective, load centers perspective, transmission grid perspective, as well as future planning and all such engineering aspects concerned to the energy control center operation is under the action. Definitely the energy dispatcher sitting in the energy control center find all these data available on his screen on the hierarchy of his role. Then definitely the current screen or current role what he has been given make him knowledgeable about the system what he is operating. And the system is providing you the real-time, real view of the information and the contingent changes what are happening in the power system right now is really monitored by those operators. Hence, it ensures the fail-safe system. The fail-safe system means before readily the system is going out of your control. Able to go out of your control, you are going to lose it and you are going to take care of that by the sense of those possibilities which definitely make you to get lost. So that kind of fail-safe operation is possible having a master computer side by side a slave computer in sequence. The master computer performs all the foreground activities which are very critical to operate the energy system. The slave computer, which is a parallel computing facility, which always performs background computing processes, which the output of them is very necessary to take decision on the main computer. So this ensures fail-safe, and every moment of time, one of the computer is ready to monitor the entire system and its due status. So anything likely going adverse, You have a supervisory eye on that to see to it that such an event going worsen soon can be minimized. Impact of that can be reduced. This is how it ensures fail-safe system operation on 24/7 basis. This is a basic advantage of implementation of automation in many processes. Implement innovative technologies to ensure situational intelligence for the operator. This is a very great advantage of supervisory control and data acquisition. When this feature intelligence is utilized in the computing facilities, the situation, the current transaction, current situation is under the automation, nothing but artificial intelligence programmed into which ensure like a human, it is able to think, it is able to provide advice, guidelines, set points, probable scope for your variance. This is an intelligence which is possible in supervisory control. Suppose just say a transmission line which is getting loaded, transmitting the power on that line, certain MVA being transferred. Its capacity is known to us as its critical capacity. And right now, what is the capacity? Is 50 to 60%. Suppose the loadability is increased, suddenly load is increasing on that line. So criticality is, this system is going to alert you what right now, what is exactly increasing. The incremental change is noticed by you graphically on the screen, and it will alert you. This probably continue for an hour of time, increase the temperature of the conductor, and conductor due to temperature failure may break into. This kind of situational intelligence can be programmed. A generator which is running, suddenly load is increasing, then the load adjustment can be done on a certain generator whose capacity is not yet fully utilized. It can alert you there is a scope to increase the generation which the system can cope up for you. A generator under the observation critical to work. Suppose it is working critical next to net capacity, suddenly a further change on the demand on that would definitely cause it to stall and fail. Situationally, it will provide you a knowledge, provide you a screen full of data, handbook of information, and logs of previously such situations occurred. So this is going to provide you intelligence to the operator. Even though human being is the operator here, human being has a limited sense of design and operability. When you have been given a sufficient knowledge from the system perspective, you are able to take up a suitable decision on the situation so that intelligence the machine can provide you with a requirement. This is how the innovative technologies which a very latest state-of-art computing mechanism, state-of-art sensing mechanism, computational algorithms can make your faster decision before really it affects adverse. This situation can be brought to the control. This is how innovative technologies which ensure intelligence in situation. So it is always advisable to go for such knowledge. Ensure total observability of the system in real time. As I was speaking, SCADA, supervisory control and the data acquisition, basically a computing facility with a suitable software and hardware interface to the end-to-end devices of the geographical periphery with which it is supposed to function. The real-time view of the entire interconnected system is viewed on the screen either in full or part as required, and get the data and store it in the database for the appropriateness of its use, process accordingly, and the results of processes are used to control the system appropriately. This is a wonderful feature of the particular supervisory control data acquisition, wherein data is acquired and it is made functional to view on the screen for the observation perspective. There are so many observations that one dispatcher is permitted to operate, another is permitted on a hierarchy of roles. Therefore, unless I have an observation on the real power system, I cannot make any good decision on which. Therefore, observability is one of the important aspects. Ensure availability of correct data. So this is a critical challenge for the power system SCADA. because once I have a suitable infrastructure interconnected to the end-to-end devices to fetch the information from that field to the remote to master station, how is that real data is made available at the computing facility in real to the truthfulness of its real data? This is a great challenge. So therefore, for which the signal once it is fetched at the RTU, means remote terminal unit in the field, is encoded digitally. It is configured. It is protected from such hack, such error included to which that is encrypted, and it is transmitted over a distance to reach to the master substation where we have MTU, master terminal unit, which is going to collect the information from several RTU together, and it will store into a memory and it will be processed. It means to say that encryption is one of the important need. If the data is erroneous, surely what the data in the energy control center we are processing will be erroneous, whose output may be out of bound, which may lead to uncontrolled or something wrong decision to be initiated at the energy control center. Because the real field is far away, energy control center is somewhere else. It is connected by a communication signals or data on which the computational aspects and state estimation analysis results give a data on which the control is exercised to see to it that appropriate operation is always preserved in their plant. So if the data itself is wrong, the output of the wrong data would definitely lead erroneous result only. Those erroneous results out of bound means the operator has to try to control it off and on to bring it unnecessarily, even though system is correct. It may be due to a temporary loss of data, wrong data correct, wrong data read or communicated. There are so many data handling techniques. As the computer science engineer, data mining, data fetching, data science, that kind of wing has now established and is getting a great importance. Such data handling, data processing, pre-processing, checking for the accurateness, adequacy, all such information, such algorithms must be utilized, and the suitable data is stored in the memory. It is because continuously data is getting streamed from all the field devices to the master station. It requires enormous storage. We call it as critical data, which is very critical, but if it comes in volume, how to process it? Then there should be some data handling techniques which will reject much of the erroneous data, unwanted data, which is utilized, which is only the correct and suitable data only processed and stored in the memory. This is called as a data handling. Then integration of energy management system functions to predict grid behavior. This is a wonderful utility, like the prediction of upcoming prediction behavior of the grid, the transmission mechanism set up with the generation loads and all, how it is going to behave soon after a certain function is enabled, certain control is exercised, certain change in load is noticed, how this is going to behave, what would be the behavioral aspect of this, so what would be the counteraction. If it is readily available in the control center dispatcher role, definite to say system will be always normal, because system always find a turbulences due to dynamics of the component and the load behavior. Always, as and when there is a change, there is a control action initiated and the behavior of the system soon after that, during which has to be estimated. Is how grid behavior, how the transmission and entire power system behavior is going to be soon after this, soon on the occurrence of this, has to be understood when advanced. That is a great challenge as well as requirement of the power system. Then to do this, All this kind of computation, so-called discussion, what we have done as a benefit to the corporation, to ensure the fail-safe operation, view it and manage it, make it profitable like that, it requires a lot of end-to-end communication, end-to-end connections from device to device. So it requires a lot of communication from devices. See here, we were interacting power system for the delivery of adequate active and reactive power. But our present discussion is going on communication. So now see the vital role of communication mechanism in the power system operation. As and when automation is brought into the substation or a power system, definitely lot of equipment from the electronic perspective have been implemented. Their connectivity or their communication with the master station should happen. Therefore, communication mechanism have to be such a way strong like our power system transmission lines. If there is a loss of communication between any of the equipment to any of the next one, definitely there is a lag or there is a disconnection. It could lead to erroneous or wrong data or wrong control action. Therefore, communication channels are very critical in power system. You may have a power system network one-to-one physically existing. If the communication setups were lost, you cannot deliver your secured power to them. This is the criticality. It is nothing but you have every resource. Generators are there, transmission mechanism is there, loads are demanding. You have an ability to transmit the power. End-to-end confirmation from the communication is sorry. End-to-end communication is not happening. Acknowledgement of reception of power and acknowledgement of sent of bulk of power is not appropriately communicated to the end device. How do you ensure system's normal state of operation? Therefore, this paragraph needs or enlightens a communication channel need. This is how there are different communication standards available. Power line carrier communication, microwave communication, fiber optic communication, satellite communication. It means, as you are aware, we can communicate with the end devices connected to the same power grid through our existing power transmitting line at the radio frequency, which is a power line carrier communication. It means what the power we are transmitting on the particular transmission line, end to end of the devices, I can connect the LC circuit and I can make the power line carrier communication mechanism. We will see in the next interaction class. I have characteristics of this by another slide only. I will try to present it. So the one mode is using the power line itself for the communication from end to end. I can use PLCC, power line carrier communication. It should have end to end devices to acknowledge what it is being transmitted, what it is being utilized using the communication line. This is a setup of utilization of the existing power line from the communication point of view. But it has its own adverse effects or drawbacks, and the power line is not in a state of communication. This communication cannot be established. The next is microwave communication. The present microwave communication is gigahertz scale, end-to-end devices. End-to-end device. I go back to the slide, it will be easier for us to see. This is how I was speaking about. And here, exactly. I am trying to communicate with you this kind of communication. It may be a radio or microwave communication from the field devices. How it gets communicated to the field or a base station like this way. So the communication may be a PLCC, power line carrier communication. It may be a public telephone line, or it may be a power line from end to end. I can connect a device to device to transmit the information. Or it may be a microwave communication from end to end. I can connect and handshake the data. Or it may be a satellite. From the point of station where it is not possible for me to lay transmission line or the PSP line or a microwave is not there nearby, satellite point-to-point communication can be utilized. So it can be any one of the mode of communication which the data need to be transmitted from one station to another. This is what I have. Power line carrier communication, microwave communication, satellite communication, or fiber optic communication. This is a latest mode of communication for very low loss mechanism with a high bandwidth transfer of data. So these are the four different communication mechanisms which are highly prescribed for the power system SCADA, in which you will find the power line carrier communication getting obsolete, and the only communication right now is rest of the field. It is the microwave communication, fiber optic communication, satellite communication, and that. So in the next class, I will just project the information related to this and some data along with that. Moving to that, the functions which we have seen in the earlier interaction, this was what I have seen, and the next heading I would like to begin is unit commitment. Before going to that, in the next class, I will just try to make another 10 to 20 minutes of discussion and some slides which will project you these drops, the single 2-point, or this is multi-drop, or RS232, or star topology, and this comparison, whichever